Now some practical notes for Lab 5. The first thing you notice is that I'm using polarized capacitors in my circuit, and you should as well because you'll be using electrolytic capacitors, which are indeed polarized. So the second thing about electrolytic is that you need to go through your circuit and make sure that you know the DC voltage at the two ends so you know which orientation to use. So C3, for example, it's 0 volts on the right, and it's somewhere between -9 and -3 volts on the left. So it needs to be oriented with the negative to the left. RB here, we know there's 0 volts on the left, and it's slightly less than 0 because of the base current on the right. Our C2, it's 0 on the right, and it's somewhere around +3 on the left. So note the orientation of each of these and make sure you do that. And going forward, anytime you need an electrolytic capacitor, which anything above about 50 mics or so, you're going to need an electrolytic to do it. You want to be able to orient them and check that. The second thing is that you may be tempted to choose a series or a parallel combination of resistors to get closer to your design value for your resistors. Resist that temptation. It's not wrong, but it's more expensive. And you're going to be doing the loop anyway to where you compute your operating point based on the resistors you chose. So you can answer the question, well, is the resistor that I picked close enough? If it's close enough, if your operating point is close enough. And I already mentioned the practical note of when you're checking for saturation, when this thing's in the limits of linear operation, you want to put the scope on VC and VE and look at VCE. And when you're checking for cutoff, you want to put the scope on 9 and VC and check for where VC is equal to 9, or equivalently, IC is equal to 0. So that's how you're going to check those two things in lab.